I'm Ms. Hearn. Let's get started.
Now, one of the reasons why slope is so important to us is we can use the slope in order to graph the line. If we rearrange the equation of a line into a form where y is by itself on one side, that's called the slope-intercept form of a line, because the number in front of the x is the slope, which is why we call it m. And then the number at the end, the constant term, is going to be the y-intercept, because if you plug in 0, it's going to clear out that first term and you'll be left with just b. This is a very useful tool, this slope-intercept form of a line. Let's look at how we can use it. Write the equation in slope-intercept form and then graph the line using the slope and y-intercept. When we want slope-intercept form, you're just basically solving for y. So I have the equation 2x minus 5y equals 0. I need to get y by itself. What should I do first? Good, subtract 2x. So we have negative 5y equals negative 2x. And then I'm going to divide both sides by negative 5, and that's going to give me y equals 2/5 x. Now, we're supposed to graph this using slope-intercept form to identify the slope and the y-intercept. This doesn't quite match up very nicely with this equation, though. What's missing here? The b. So what is b if we can't see it, if it's invisible? Yeah, b is still there, right? It's 0. Good. B is 0. So we have a y-intercept of 0. Okay, my y-intercept is going to be, instead of 0b, and we know it's 0, 0. And my slope m is what? 2/5. Use your y-intercept as your starting point, and then the m, the slope, tells you the direction to get to the next point. This can generate points. We could use it to generate points forever. Let's start by plotting our starting point, 0, 0. Whatever the y-intercept is, that's what you plot first. And then we're going to interpret the slope as a direction. What is the slope telling us to do? A slope of 2/5, positive 2 over positive 5, is you to go rise up 2 and then go to the right 5. So starting at 0, 0, if I go up 2 and to the right 5, I'm going to find myself at the pair of coordinates 5, 2. And I could keep doing that. Go up 2 more and to the right 5 more. And what pair of coordinates would I find myself at? Good, 10, 4. And in fact, what you can always do is just keep adding 2 to the y and adding 5 to the x, and you'll get more points on the line. But it's not just adding that will work. Keep in mind that a slope of 2/5 could also be thought of as negative 2 divided by negative 5, because when you divide a negative by negative, you get a positive. So alternatively, I could have gone down 2 and to the left 5. So let's go back to 0, 0. And see what happens if we go down 2 and to the left 5. Okay, if I go down 2 and to the left 5, what pair of coordinates will I find myself at then? That's right, negative 5, 2. And if I go again down 2 and to the left 5, what would be the next pair of coordinates? Negative 5, negative 2, and then where would we go? Negative 10, negative 4. Good. Okay, so now let's connect the dots. Don't forget to connect the dots. It's not a graph of a line until it's connected, because every single tiny little dot on this line is a solution to the equation. And by the way, I really hope that at home you're actually drawing these graphs out on paper. When you draw a graph out on paper, you use your brain in a different way. You process the information differently. Watching a graph or graphing on Alex, it's not the same as actually physically graphing on paper, and it's really an important part of conceptualizing what's happening. So please do take the time to practice on paper.
I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.